called the sum and difference formulas. And what's nice about today's formulas is you do not have to memorize them. These are formulas that will be on the quiz tomorrow, and they will be on your test next week. So you can just reference them at, like, literally on your quiz and test. Okay? So you have, I've given you a piece of paper, and we're going to fold it and make kind of like this booklet type thing. So the first thing I need you to do is I need you to fold it, but look at me please. I need you to fold it along this vertical line, but that vertical line goes inside. So you can either fold it so you can get it on the vertical line and then fold it the other way, or you can just try really hard to get that folded inside, but the fold does need to be inside.
Not that.
Then if you open it back up, there are horizontal lines. Stick to the side that doesn't have sum and difference formulas written on it, and you need to cut horizontally to the fold. You need to cut horizontally to the folds. And then stop.
Hey, I don't know, can you toss it there?
No. That's what I said.
Oh, sure. Okay. I was expecting
Cut to the fold. And then you should have like 3 flaps. It's kind of a little. What? Okay, now you can choose to either put this in your folder, or when we're done, you can tape it into your notebook or staple it into your notebook if you're really particular about having things in your notebook. But I thought it would be nice to have all of these together, and I don't want you to risk writing down the formula incorrectly. Okay? Are we all done with our cutting? So go ahead and close all of the flaps so that you see the 3 formulas. Okay? Technically we have 6 formulas here, but they've squished them to be in only to 3. Okay? So this first one, it says the sine of u plus or minus v. So if we are adding or subtracting angles inside of sine, we can break it up in this manner. Okay? The sine of u times the cosine of v plus or minus the sine of v times the cosine of u. Excuse me, yours says cosine u sine v, doesn't it? Okay, which I like. Let's go. I'll change that. I forgot that I did that. Okay. I did that so that your angles can continue to be in the same order, right? So we have UV, UV, but we have sine, cosine, and then cosine, sine, okay? So this plus or minus, essentially that means if we're adding inside, we'll add these 2 here. If we're subtracting inside, we'll subtract these 2 here, okay? Now, go and look at your cosine formula. If we are adding or subtracting inside of our cosine, okay, we can't just break apart a trig function with addition or subtraction. Okay, remember we had all those properties for like logarithms and things like that. That's kind of what's going on here. These are, different formulas for when this happens. So when this happens, we have cosine u, cosine v, minus plus sine u, sine v. Have you ever seen that symbol? Did you think it was upside down?
Yes.
Okay, this is why I'm not having you write down these formulas, because I would worry about you writing this down incorrectly. What this means is if there's addition inside, you would use subtraction in between the two. If there's subtraction inside, you would use addition when you apply the formula. Am I nifty?
Yeah.
Okay, and then your tangent formula, a little bit more involved. Okay, but remember, you're not having to memorize, you're just having to apply these. So if we have addition or subtraction inside of tangent, we would have tangent u plus or minus tangent v. Okay, so that stays consistent, but then 1 minus plus tangent u, tangent v. Okay. So you noticed when you were cutting and folding and whatever else that now that we have this folded and cut, you can open it up and there's 2 examples for each. Okay, so we're going to go formula by formula doing examples. Okay, what I typically do right now is I show you a proof for, I think it's the cosine one. But to be honest, I need to save my voice because it's conferences tonight. Some of you probably don't even care about the proof. You just want to know how to use the formulas. So I'm just going to go through the examples and save those 10 minutes. Is that okay?
Yes.
Okay, so open up your flap for the sine ones. We are going to evaluate the sine of pi over 12, and we're going to do it exactly. Now, if we punch it into our calculator, are we going to get an exact value, or are we going to get a decimal? We're going to get a decimal. Okay, so without our calculator, first of all, I want the exact value of pi over 12. Okay, well that's not on our unit circle. But let's think of some angles that are on our unit circle that we could either add or subtract to give us pi over 12. Unit circle angles, pi over 6, pi over 4, pi over 3, pi over 2. I can keep going. But let's think of unit circle angles that would subtract or add to equal pi over 12. Okay, say that again. Is pi over 4 minus pi over 6 the same as pi over 12?
Pi over 6 is 30 degrees.
Okay, so this is like 3 pi over 12 minus 2 pi over 12 is 1 pi over 12.
Or you can make a fraction. That's a better way to explain it.
Write it down. Okay, 3 pi over 12 minus 2 pi over 12 equals 1 pi over 12. Okay, so really the only thing that I had to have you really think about is how do we get pi over 12? From here we need to apply the formula. So, close your flap, really take that formula in. Sine, cosine, cosine, sine, right? So, we need the sine of u times the cosine of v. Since there's the plus minus in the formula, we keep the same operation. And then we say cosine u sine v. Now, can we individually evaluate those trig functions?
Yeah.
Yeah. Okay. What is the sine of pi over 4? Radical 2 over 2. What is the cosine of pi over 6? Cosine of pi over 4? Radical 2 over 2. And sine of pi over 6? 1/2. So we have radical 6 over 4 minus radical 2 over 4. So I'm going to go ahead and write this as radical 6 minus radical 2 all over 4, since they would have common denominator. Questions? Besides coming up with the pi over 4 minus pi over 6, all we have to do is apply the formula and evaluate. All right. Is there a second example there? Okay, look at it. Okay. Now, do you see a pattern? Sine 120 cosine 60 minus cosine 120 sine 60. Okay, does that look like the sum or difference formula? Okay, so what we are able to do is we are able to condense this down. This is the sine difference formula. This is the same thing as the sine of u minus v. So really what we're looking at is the sine of 60 degrees. Which is radical 3 over 2. Any questions about the sine formula? Okay. Go ahead and close that flap. Stare at that cosine formula for a moment. Notice how the cosine formula goes cosine, cosine, sine, sine. And in between it's minus plus, so that sign gets flipped. That is important. Okay, open it up and look at that first example. Simplify the expression. Okay. I'm asking you to simplify this expression. It's cosine where there's two angles added together inside. Well, if there are two angles added together inside, then we have no choice but to use our sum formula. If we have two angles added inside of our cosine formula, then we can rewrite it as the cosine of the first times the cosine of the second angle. What would go here? Minus, since it's addition inside, we switch to subtraction, sine of the first angle times the sine of the second angle. That's how we would apply the formula. So cosine, cosine with our two angles. We switch the operation sine, sine with our two angles. Okay. Now, cosine of theta, sine of theta, we can't really do anything with that. But do we know what the cosine of 3 pi over 2 is? Is it 0? Okay, and do we know what the sine of 3 pi over 2 is? -1? Huh. So we have positive sine of theta?
Yes.
Question. Alright, we're just moving right along here. Go ahead. What am I asking you to do in that next example? Verify the identity. So this is what we did last week, right? With the step-by-step showing how both sides are the same. So if I ask you to prove an identity or verify an identity, we're trying to get the right side to equal the left side. Okay? Now, what I need you to recognize is what our first step has to be in this case. Okay? Well, we have subtraction inside of cosine. And if we have subtraction inside of cosine, then we have to use that difference formula. That's literally the only thing we can do right now. Okay? So let's go ahead and apply that cosine difference formula. Okay? We have cosine with our two angles. And then what's our operation in between? Plus, since it's subtraction inside of our cosine, it's plus in the formula. And then sine. Okay, so my reason is going to be the cosine difference formula. Anytime I ask you to prove or verify an identity, yes. Okay, well now how am I going to get this left side to look like sine of x? Okay, so we know the cosine of pi over 2 is 0. Anything else? The sine of pi over 2 is 1. Okay, I'm just going to put my reason as evaluate because I know that the cosine of pi over 2 is 0. Okay. How many more steps do we have? 1. Cosine times 0 is? 0. Plus 1 times sine of x. My left and right side equal. I'm just going to write simplify as that last reason. Okay. Really, the sine and cosine formulas aren't that bad. Okay? First of all, they're going to be given to you, and so you're going to be able to see them no matter what. You just need to be able to use them. Okay? They're fairly similar to each other, which I think makes it nice. The biggest thing you're going to have to watch out for is the plus or minus plus situation. Also, please look at this. This is subtraction. This is not a negative angle. I also need you to keep that in mind. Okay? It's okay that this is subtraction. We still call this second angle x. Okay, now go ahead and take a look at your tangent formula. The tangent formula has a little bit more to it. It's a fraction, and we have two of those signs to worry about, plus minus and minus plus. But that's okay. Okay, so we're going to simplify this expression. I need you to notice that we are adding two angles inside of our tangent function, which we don't usually see. We can't break that apart without using this formula. Okay, that's why we have this formula. So, tangent of theta plus 3 pi. Since we are adding those two together, we can write the tangent of the first angle plus the tangent of the second angle all over in the denominator of our formula. We have 1 minus plus. So since it's addition here, we keep the addition here but change it to subtraction here. Oops. 3 pi. Okay, what is the tangent of 3 pi? So the tangent of theta plus 3 pi is the same as the tangent of theta. There you have it. Okay. Now I do need, we've seen this a couple times. This is like the third example we've seen where we've had to evaluate inside of our function or inside of our work. Please make sure you put this step where you're replacing them with 0 and then another step where you simplify.
How is the tangent of theta divided to 1 minus 2?
Well, this is 1 minus 0,
Yeah.
and so we get tangent over 1. Okay. Make sure I see that step where you're evaluating it to be 0 and then simplify from there. Okay? All right, we've saved the best example for last.
Whoop.
I want the exact value of 255 degrees. Is 255 on our unit circle? No. We need to think of two angles that either add or subtract to 255. At your pod, brainstorm for me. Brainstorm. Okay, unit circle values. Unit circle values. Okay, what are we coming up with? Who has something for me?
5 pi over 3 minus pi.
If it's degrees, keep in degrees. If it's radians, keep in radians. How do you feel about this? Does that work? Okay. So tangent of 300 minus 45. I will give you a suggestion when you're doing these problems. Try to avoid any of the pi over 6 or 30-degree reference angle values when you're doing the tangent problems, because the tangent of pi over 6 is radical 3 over 3, and it gets a little bit messier. So if you can avoid it, I would suggest trying to go for a 60-degree reference angle, okay? And you'll see why I'm going to urge you to be less messy when we get into the problem, okay? So our tangent difference formula is the tangent of u minus the tangent of v all over 1. Since it's minus here, we switch to addition here, tangent u, tangent v. Okay. What is the tangent of 300? Did you have a question? Okay. What's the tangent of 300? Well, that would be the radian measurement. Yes. Negative radical 3. Any of the 60-degree reference angles are going to have a tangent of radical 3. Since we are in the 4th quadrant, the tangent would be negative radical 3. The tangent of 45? Yeah, that's nice. Over 1. This would be negative radical 3. Okay.
You got it.
Here.
I'll give it.
Okay. Now, do you think that this is how I'm going to let you leave your answer? No, I am not. Why? There is a radical in the denominator. So in order to rationalize our denominator, we must multiply by the conjugate. Good job. Which means we have to do that in the numerator as well. What do you want to do first, numerator or denominator? Denominator. Denominator is nice because it is a squared minus b squared. We're multiplying by conjugates. We know those middles are going to cancel out. Okay? Now we're not so lucky in our numerator. First times first is negative radical 3. Outside would be negative 3. Inside would be negative 1. And last would be negative radical 3. Questions on any of those numbers? Do you agree with all those numbers? Okay. So in our numerator, we have negative 4 minus 2 radical 3. And in our denominator, we have negative 2. Okay? Each of these are getting divided by negative 2. So negative 4 divided by negative 2 is a positive 2. And negative 2 radical 3 divided by negative 2 is a positive radical 3. Here is the exact value. Okay? Those tangent problems take a little bit more work than the sine and cosine ones. That's fine. Just make sure you're rationalizing your denominator. Also, can you imagine if we had radical 3 over 3 instead of radical 3? That would create more work. So I would urge you to really think about your 60-degree reference angles instead of your 30-degree reference angles because they're easier to work with. Okay, do you have a quiz tomorrow?
Yes.
So you should do your homework.
Yes.
There are even a handful of you who, given the extra day off, didn't do your homework when I said you have to do your homework. So some of you have 2 homework assignments you need to do before tomorrow. Get it done. Okay? Conferences are tonight. I'll be there.
No, man.
Ava.